Hello, my name is Lily Whitesell and this is Lab 5. For my Lab 5, I chose to do the Human Rocket Lab. Introductory information that you will need for this lab is that a man named Felix Baumgartner attempted and succeeded to break the sound barrier by jumping from a balloon 120,000 feet in the air. This is about 36,576 meters up in the air. Baumgartner wore a suit to help with the increase in temperature and the pressure and oxygen levels at such high temperatures and altitudes. His weight with the suit was about 110 kilograms. It took Baumgartner about 4 minutes and 19 seconds to reach the surface, and the speed of sound is 343 meters per second. Objectives for this lab is to create a model for air resistance and examine the outside factors of Felix's fall, and to use Newton's second law to understand the changes in velocity and position. Equations used in this lab are such. Ones that are familiar are the velocity prediction equation and the position prediction equation based on Newton's second law, and the air resistance equation, which uses air density, the drag coefficient, a cross-sectional area, and the velocity. And then some new equations have to do with the gas laws in order to calculate the changing density. We needed to find pressure and changing temperature to find density. And we had to use the gas law constant R. To create a model for air resistance, we needed to use some of these factors. Our height, once again, was 36,576 meters. Our mass was 110 kilograms. The cross-sectional area was approximated to be about 0.5 meters squared. And then the coefficient of drag we had to find we had to estimate based on our glow script code, and it was estimated to be around 4.67. We'll go into more depth about that in just a second. And then the air density was calculated by the equation that we saw before in the previous slide, and the velocity was found based on Fnet and the change in position and the change in momentum. Terminal velocity was something that we needed to look at in this lab. It's constant velocity that occurs whenever drag and gravity are equal and opposite. Our terminal velocity will be changing due to the change in air density. So whenever we look at the growth script code, we can see that the time is set to be 259 seconds, which is the equivalent to 4 minutes and 19 seconds. We use our temperature equation from the previous slide and our pressure equation from the previous slide, all in order to calculate the density, which was based on the gas laws. The change in altitude and the change in air density. As altitude decreases, air density will also decrease, as you can see in the C, and there's a link to the glow script code. And then the change in temperature will increase as air density decreases. So as Felix was moving towards the Earth, his temperature was increasing. The increase in temperature. The temperature of Felix's suit will increase by 1 degree Celsius for every second of descent. To keep Felix safe, the suit had to be made with this in mind. And then the speed of sound. The speed of sound was broken whenever he jumped from 100,020 feet. And the speed of sound is 343 meters per second, which is Mach 1, and whenever he jumped, he hit about Mach 1.25. Thank you for watching. These are the sources